Okay guys, we're going to get started with 5.2, which is all about quadrilaterals. Some of the stuff might be vaguely familiar, some of it is actually from elementary school, most of it is new. So first of all, we're going to jump right into some new terminology. So it says when parallel lines are intersected by a transversal, several angles are formed. When you know the lines are parallel and you know one of the angles, you can determine the rest of the angle measures because they're related to each other. Okay, so the first thing you need to know is what exactly a transversal is, and it's often a definition off to the side. Transversal is a line that intersects two or more lines at two distinct points. So it's a line that crosses two or more lines at separate points. So if we have any two lines and a line that crosses them at two or more points, this right here is a transversal. Okay, it's a line that intersects two or more lines at two distinct points. Okay, so in this diagram right here, it says in the following diagram, L1 is parallel to L2. What are the measures of the indicated angles? Parallel lines are special. Parallel lines are special because if a transversal crosses parallel lines, then the angles are the same from one set to the other. So we have two lines, L1, L2, and the line that crosses both of them is our transversal. Okay, so what that means is our angles up here are equal to the angles down here that are in the same position. So angle 1 is above the parallel line and to the left of the transversal, which means the angle down in the bottom that's above the parallel line and left of the transversal is actually the same size. So angle 1 is equal to angle 5. They're the exact same size so long as L1 and L2 are parallel. We show that L1 and L2 are parallel by putting these little arrows on the line. It tells us they're parallel lines. Same thing for 2 and 6. So 2 is to the right of the transversal above the parallel. 6 is to the right of the transversal above the parallel. So angle 2 is equal to angle 6. Angle 8 and angle 4 are equal to each other. And angle 3 and angle 7 are also equal to each other. Okay, so the angles in the exact same position are equal to each other along that parallel line, so long as those two lines are parallel. So already I know that if angle 2 is 75 degrees, angle 6 is also 75 degrees because they're equal to each other. They're in the same position. Another thing we need to know is about supplementary angles. Supplementary angles are two angles that add up to 180 degrees. And when we're looking at transversals and parallel lines, the two angles that we really care about that add up to 180 degrees are going to be the angles along a straight line. So a straight line is always 180 degrees from one side to the other. What that means is if I know one side of that angle, I also know the other side because the two of them have to add up to 180 degrees. So if I have, I'll draw it at an angle. If I got a straight line intersected by an angle, and let's say this is 110 degrees, this side is going to be 180, minus 110, so 70 degrees. They have to add up to 180 degrees. I can also look at my straight line going this way as 180 degrees, which means if this top piece is 110, this bottom piece down here is also 70. Doing that in the question that I have, I'm going to go back to right here. This is 75 degrees, so anything along a straight line is going to be 180. So if this half is 75, this half is 180 minus 75, so 105 degrees. So that's what it's doing right here. It says angle 1 lies on the same line as angle 2, so they're supplementary. So 1 and 2 make 180 degrees. So angle 1 is 105. Angle 5 is also 105 for the same reason. And we know angle 1 and angle 5 are equal because they're in the same position. Okay, the next thing they say is angle 3 is also on the same line as angle 2, so they are also supplementary. As well, angle 3 is vertically opposite to angle 1, so angle 3 and angle 1 are equal. So what this is telling us is because 2 and 3 are along that transversal line, they also add up to 180 degrees, so 3 is 105 degrees. But when we have angles that are vertically across from each other, so this angle and that angle are equal. They're exactly the same size because they're formed by the same lines. Then this angle right here is also equal to the angle across from it. So they're calling them vertically opposite. It's really sort of the angles that are at the diagonal to each other. They're equal to each other. So for that same reason, if angle 6 is 75 degrees, that means angle 8 is 75 degrees. And if angle 5 is 105 degrees, angle 7 is also 105 degrees. They're opposite to each other, they're diagonals to each other, so they're equal. And if we look, all of those straight lines add up to 180. Okay, so now it's just going to go through the rest. 4 is vertically opposite to 2, so they're equal. On the next page, 5 and 1 are corresponding angles. That is, they occupy the same position relative to the parallel lines in the transversal at two different intersections. Corresponding angles are equal. So that's the ones that are at the same pair that we wrote on this first page. These right here are known as the corresponding angles. Okay, so 1 and 5, 2 and 6, 3 and 7, 4 and 8 are corresponding. They're in the exact same position along the parallel and the transversal. They're known as corresponding. Corresponding angles are equal to each other. This part where it says angle 6 is an interior angle on the same side of the transversal as angle 3. Interior angles on the same side of the transversal are supplementary, or they add up to 180 degrees. So what this is saying is, if we have our two parallel lines and our transversal, angle 3 is right here, angle 6 is right there. 3 and 6 are both interior angles. Interior angles mean they're on the inside of the parallel lines. So interior angles are supplementary. That means they add up to 180 degrees. So we knew angle 3 was 105, which means angle 6 has to be 75 because the two of them together have to add up to 180. Okay, so interior angles are supplementary, straight lines are supplementary. all of them add up to 180. Okay, so there's lots of different ways of going about this. You can look for corresponding angles, you can look for supplementary angles, vertically opposites are equal, corresponding angles are equal, all of them. There's a million different ways of finding these things. You just have to look at what you know and where those angles actually are. Okay, so this next one, it says, in the following diagram, L1 is parallel to L2. What are the measures of the indicated angles? You have to be careful when they give you more than one transversal. So this right here is a transversal. And this over here is also a transversal. The problem is the transversals, or the angles along those transversals, only correspond to that specific transversal. So when I look at this first one right here, this 110 degrees is along this transversal line, and it has absolutely nothing to do with anything along the other transversal line. So I'm going to use a different color for this side. This transversal has to do with angles 120, 4, 3, and 2. On the other side, the 110 and the 1 are part of the same thing. So angle 4 has nothing to do with that 110. They're not corresponding angles. Corresponding angles have to be along the same transversal. So if we're looking at this blue one first, this 120 is to the right of the transversal and it's below the parallel line, which means its corresponding angle down here to the right of the transversal below the parallel line is the same angle measure. So this is going to be 120 degrees. If we look at number 4, 4 is along a straight line with the 120. So that has to add up to 180 degrees. So something plus 120 is 180, and that something is 60 degrees. So that straight line has to add up to 180 degrees. Then 4, being to the left and below the parallel line, will be a corresponding angle to the angle that's to the left and below the second parallel line, which is angle 3. So angle 3 is also 60 degrees because angle 4 and angle 3 are corresponding angles. Okay, angle 2 is 120 degrees because it's corresponding angle as well. And angle 4 is 60 degrees because it and the 120 are supplementary angles. On the purple line, on the other side, this 110 and angle 1 are kind of special. We can figure out what that is, what angle 1 is based on that 110. So I'm going to fill in all the angles that would be 110. So my corresponding angle would be 110. So to the left and below, to the left and below. My diagonals would also be 110. So this up here would be 110 because vertically diagonal or vertically across from each other angles are equal, which also means this angle 1, which is directly across from the 110, is 110 degrees as well. Okay, so I know all of my angles now, and I know them based on the properties of parallel lines and transversals. Okay, this only works for parallel lines. So as soon as it says parallel in your question, these are my parallel lines, this is my transversal. So it says what must be the size of angle 1 if L1 is parallel to L2. So the only thing I know is this 57. So that angle right there is 57, which means the angle that's vertically diagonal or vertically across from it is also 57. I know that the corresponding angle to that 57 is also 57. So if this is my position, then this is my corresponding angle. That's also going to be 57 degrees. With that 57, I can now find angle 1 because this right here is a straight line that adds up to 180 degrees. So angle 1 is going to be 180 degrees minus 57 degrees, which is going to be 123 degrees. Okay, there's lots of different ways to do this. You could have done the vertically opposite, so from 57 to 57. This one right here makes this one right here 57. And then we could have done the 180 here. Doesn't matter. Doesn't matter how we do it. It's going to be the same answer either way. Okay, but the thing you're looking for is those two parallel lines and figuring out which one is your transversal. And the transversal is the one that has to cross both of those parallel lines. Okay, the reason why we start with transversals and parallel lines is because we need to learn about quadrilaterals. So a quadrilateral is a four-sided polygon lying on a single plane. Or a quadrilateral is a closed four-sided figure that lies on a single plane. That is, the sides meet at four corners or four vertices, and the figure lies flat. So vertices are corners. The sum of interior angles of a quadrilateral is always 360 degrees. So when we add up a triangle, it always adds up to 180. When we add up a quadrilateral or a four-sided shape, we add up to 360 degrees. There are several kinds of quadrilaterals, each with additional properties as shown in the following diagram. When you add another property, you get a new quadrilateral, and each quadrilateral has all the properties listed above it. Okay, so this is a breakdown of the different types of quadrilaterals. You should know these. Okay, you need to know these. You need to know what properties these things have. So quadrilateral is our broad category. Quadrilateral, quad means four. It's just saying it has four sides. Quadrilaterals can be broken into three main types: parallelograms, kites, trapezoids. So for a parallelogram, it says right in the name parallel. Parallelograms are two pairs of parallel sides. So the top and the bottom are parallel to each other, and the two sides are also parallel to each other. So that's when we have two pairs of parallel sides. If we only have one pair of parallel sides, we have a trapezoid, where the top and bottom are parallel to each other, but the two other sides aren't. And then if we have no parallel sides, we have a kite. A kite is two pairs of congruent sides. Congruent sides are the same sides. And our diagonals intersect at 90 degrees. So we have 90-degree corners on our kite. So the top two are the same size, the bottom two are the same size, but there's no parallel lines. Congruent just means the same size. If we go back to the parallelogram part, parallelograms can be split into more complex shapes. So a rectangle is a parallelogram that has four right angles. So a rectangle is all right corners. The top and bottom are still parallel to each other. The sides are still parallel to each other, but they're different sizes now. The top and bottom are the same size. Left and right are the same size. Rectangles can also be turned into squares. Squares are four right angles and four congruent sides. So all of these side lengths are the same size. If we slightly squish a square, we get a rhombus. Rhombus has 4 congruent sides, so they're all the same size. They're just not 90-degree corners anymore. So rectangle, square, you should be very familiar with. Rhombus is just a squished square. All the sides are the same length, but now we don't have those 90-degree angles. If we look at the trapezoid, we can split it as well. We can have a right trapezoid that has 2 right angles in it, or we can have an isosceles trapezoid where the 2 sides are equal to each other in length. Just like an isosceles triangle has 2 sides that are equal to each other in length. For trapezoids, still parallel lines, top and bottom though. Okay, so you should be at least vaguely familiar with all of these words by the time you're done this section, and you should be able to draw some of these shapes. You should, if it says a right trapezoid, make sure you know how to draw a right trapezoid. Okay, so when you're classifying a quadrilateral, it's important to be as specific as possible. For example, although a square can be classified as a parallelogram, you should actually identify it as a square. So saying that a square is a parallelogram is less helpful to us than knowing that it's a square, because knowing it's a square means it has all the same same size side lengths. So be as specific as you possibly can. Okay, the reason why it matters what type of quadrilateral it is because they have properties that help us. So example A says find AC, so the length of AC, angle A, and angle B. What type of quadrilateral is quadrilateral ABCD? Okay. If we look at the basic shape of this from A to B, C, D, if we look back at our chart on the previous page, this is a quadrilateral. It has 4 sides. It's a trapezoid because it has 1 pair of parallel sides. We've got this piece and this piece that are exactly the same. When I look at these 2 angles right here, my bottom angles are equal, which means my side lengths are also equal. If I have a trapezoid that has equal side lengths, I have an isosceles trapezoid. As soon as I see those equal angles, I know those 2 sides have to be the same length. Just like for an isosceles triangle, those bottom 2 angles are equal, which means those side lengths are also equal. So this is an isosceles trapezoid. This helps me because now I know the answer to finding the length of AC. AC is this line over here. It's the same size as its opposite side, which was 4 centimeters. So it's also 4 centimeters. If I want to find my angle measures, I can think of this as 2 parallel lines in a transversal because this is parallel to this line. If I extend them out, this is my transversal. So because these are parallel, that's my transversal. I can look at all of my properties that I talked about on that first page of the notes. So my corresponding angles are equal. My diagonals are equal. I have supplementary angles, all of those things. So when I look at the 60, its corresponding angle is going to be up here. So that's going to be 60 degrees. What I want is angle A and angle B. Angle B is this piece. Angle A is this piece over here. To find angle B, I now have a straight line where I know part of it, and I know the whole thing has to be 180. So this chunk is going to be 180 minus 60, which is 120 degrees. Then I have 2 choices. I can think of the other side as a transversal as well, extend it out, do the same thing, or I know that all 4 of my angles in a in a quadrilateral have to add up to 360 degrees. So this piece up here is going to be 360 minus the 3 angles that I know. So 360 minus 120 minus 60 minus 60 is 120 degrees. So angle A equals 120 degrees. Angle B also equals 120 degrees. Same thing here. For a kite, we know that this side and this side are equal, and this side and this side are equal to each other. And we know that everything meets at right angles. Because this corner out here is 101 degrees, we also know this corner right here is 101 degrees. Okay, so it's asking us to find the length of WX. So WX is this piece from W to X. And because I know it's the exact same size as the one on the other side, the 2 centimeters, this is also going to be 2 centimeters. It also wants to know the angle XYZ. So from X to Y to Z. If you think about this as a shape with symmetry, we could fold it directly on top of each other. And this angle over here, the 101, would line up with this 101 if we folded it along this center line, which means they're exactly the same size. So angle XYZ is 101 degrees. The last thing it wants is what's the sum of WXY and YZW. So I'm just going to redraw my kite. So I've got W, X, Y, Z. And angle WXY is from W to X to Y. So this top angle up here. Angle YZW is from Y to Z to W. That angle down there. I know in a trapezoid or in a kite or any quadrilateral, my angles add up to 180 degrees. So I know this is 110, and I know this is 110. So it's saying if I add or sum means add angle WXY and YZW, I've got these two added together. My total has to be 360 though. So 360 minus 110 minus 110 is 140. So if I add up my top angle and my bottom angle, it's going to add up to 140 degrees. Oh, sorry, this isn't 110, this is 101. So I'm doing 360 minus 101 minus 101. Which is actually going to be 158 degrees. Okay? These two angles, the top and the bottom, aren't equal. I can't just divide this in half and say that half's at the top, half's at the bottom. If you look at them, they don't look the same. So I don't know which piece is which or how big at this point, but I do know if I added those two angles up, they would equal 158 degrees. Okay, the rest of this is the solution. They go through it step by step as well. Read through it if you want. It's a different explanation than the one I used. So just have a look through it, see if it makes sense to you. Okay, build your skills number 3 says using a ruler and a protractor, measure the side lengths and angles of the following quadrilateral. What kind of quadrilateral is it? This means physically take out a ruler and take out a protractor and measure your angles and measure your lines. If you do it, and on my photocopy, my numbers might be slightly different, but I got that this is 2.5 centimeters, 2.5 centimeters, 2.5 centimeters, and 2.5 centimeters. When I measured the angles using a protractor, I got 75 degrees, 106 degrees, 75 degrees, 106 degrees. So it's not going to add up exactly to 180. Just slight probably error in the photocopying. It's been photocopied a few times. But when I look at it, this looks to me like a rhombus. It looks like a square because all of my sides are the same size, but it's squished over to the side. It's a square that's been squished, and a square that's been squished is a rhombus. The next one says, using your knowledge of the properties of quadrilaterals, find the measures of the missing angles. What kind of quadrilateral is this? Okay, when I look at it, I've got my two parallel lines on the top and the bottom, which means this is going to be some sort of a trapezoid because my other two sides aren't parallel. When I look at my other two sides, it's telling me that they're the same length. So two parallel lines and two sides that are the same is going to be an isosceles trapezoid. And I know that for an isosceles trapezoid, the top two angles are equal to each other. So angle P and angle Q are going to be equal. And I know that angle S and angle R are going to be equal to each other. That's a property of the isosceles trapezoid. So if this is 118 at angle P, it's also 118 degrees at angle Q. I need to find angle S and angle R, but I know that they're exactly the same size as each other. And I know that a quadrilateral adds up to 360 degrees. Okay, so I know my thing's going to add up to 360. So I have 360 degrees minus the two angles that I know. 360 minus 118 minus 118 is 124 degrees. So I've got 124 degrees left over to kind of allocate inside of my shape. And I know that angle S and angle R are exactly the same size, so half of this 124 is going to be at S and half is going to be at R. So I'm going to divide it by 2, which means each angle is going to be 62 degrees. So I've got 118, 118, 62, 62. Okay, those are my properties of quadrilaterals. So because I could figure out that it was an isosceles trapezoid, I knew that those angles had to be equal to each other. That allows me to find the rest of the angles in my trapezoid. Okay, the next one says, a rectangular window is to be constructed with strips of colored glass that run parallel to each other and diagonally as shown. At what angles must the glass cutter cut each of the indicated angles? Okay, so we kind of got to look at what we have going on here. I'm looking for angles 1, 2, 3, and 4. And if I look at the shape that 1, 2, 3, and 4 is in, that's the shape I've got. And it says all of the strips run parallel to each other, which means this is parallel to this, parallel, 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 all the way across. This is super helpful because what that means is all of these angles are going to be the same no matter where I am on my triangle. So this 38 degrees down here means that it's also 38 degrees here, and it's also 38 degrees at angle 1. They're all parallel to each other. They're all exactly the same. If they're all parallel to each other, that also means that this side length right here and this side length right here are equal. These are parallel. So I've got two parallel sides, two equal sized sides. This again is an isosceles trapezoid. And I'm just going to redraw it a little bit bigger to work with. This is 38 degrees. These are parallel. These are the same size. So the ends of my same sized angles, so what was 1 and 4 up here, are equal angles. We just talked about that in the last example. So if this is 38 degrees at the bottom, angle 4 is also 38 degrees. So I need to find 2 and 3. I can do it a couple different ways. If I look at this angle 2 as being part of a straight line, where this is 38, then all the way around my straight line is 180. So 2 is going to be 180 minus 38, which is 142 degrees. So this is 142 degrees. The other way I could look at it is angle 2 and angle 3 are part of a quadrilateral where I know 2 of the parts. And angle 2 and angle 3 have to be equal to each other because they're also at the ends of those same sized sides of my isosceles trapezoid. So I could find angle 2 and 3 because I got 360 minus 38 minus 38. Which if I work it out is 284 degrees. And that 284 degrees is being shared between angle 2 and angle 3, which are exactly the same size. So I'm going to divide this by 2, which gives me 142 degrees for each of those pieces. Okay, go about it 2 different ways, same answer in either case. So if you like the properties of quadrilaterals, use the properties. If you're good with straight lines equal 180, those are those supplementary angles, stick with the supplementary angles. That's always going to work as well. It just depends on what you see first, what you like best. Okay, so again, it goes through it right here. If you want another explanation or a different explanation, it could be slightly different than what I said. This next one is talking about what do we have to do to make sure something is parallel. So 5 says the transmission tower is being built to provide power to a new residential subdivision. On the tower, braces AB, CD, and EF must all be parallel to the ground. So we've got AB needs to be parallel to CD, which needs to be parallel to EF, which needs to be parallel to the ground. If this is true, then I should have two parallel lines and a transversal, when I look at EF, CD, and this line across here being my transversal. What that means is my corresponding angles should all be equal to each other, and my supplementary angle should all add up to 180. Right now, it's not actually parallel, and I know that because the numbers aren't the same. So A says, what adjustment needs to be made to angles DCF for CD to be parallel to the ground? So it says the adjustments will be made by raising or lowering CD at point D. So right now, it's telling me EF is actually parallel with the ground. So this 43 degrees is right, which means its complementary angle, so up here, should also be 43 degrees. I've got two parallel lines and a transversal. And if this angle is 43 degrees, or supposed to be 43 degrees, so it's parallel, that means this diagonal angle should also be 43 degrees. It's not. It's 41 degrees, which means right now, line CD is not parallel to line EF. To fix it, I'm going to have to raise CD at point D by 2 degrees. So we need to raise CD at point D by 2 degrees. It's going to mean that our 41 becomes 43, and then we actually have two parallel lines. The next part says, what will be the measure of angle CAB? So the angle that starts at C, goes to A, ends at B. So from C to A to B, this is the angle it's talking about. We want to know how big that angle is. Okay, and there's little bits and pieces that we kind of know already. I'm going to redraw a section of this. I'm going to redraw AB and CD with what we know about them. So we know angle AB, or line AB, sorry, is up here. So A to B. And we know we have angle C to D, or line C to D. And I have that brace that's going right here. When I look at C, if I extend things out, so if I go back to here, and if I extend out this brace, and make this come up and down, I have two parallel lines and a transversal. So two parallel lines and a transversal. And I know some of the angle measures now. I know that this piece is 43, sorry, if it's parallel, and 51 added together. So from here to here is 43 plus 51, which means here to here is also 43 plus 51, which is going to be 94 degrees. When I look for my corresponding angles, this is 94, this is 94 because they're diagonal to each other. If this is two parallel lines and a transversal, my correspondings are also 94. So if I move that out of the way, this is 94 here, which means this is 94 here. 94 below the line, 94 degrees below the line. It wants angle CAB. Angle CAB is from C to A to B, which is this guy in here. So angle CAB is equal to 94 degrees because it's a corresponding angle to the 94 degrees below the line CD. Which I guess would be angle DCE, which was 94 degrees. Okay, the last part says what type of quadrilateral is ABFE? If we go back up, AB, F is all the way down, E, back up to A. We've got two parallel lines on the top and bottom. If we're building this thing completely straight, those two sides should be equal to each other. So from E to A, F to B should be equal lengths. Two parallel lines, two equal sides, isosceles trapezoid. Okay, isosceles trapezoids are common for this because they're easy to work with. The angles work out really well. So isosceles trapezoid, when in doubt, guess isosceles trapezoid. Next one says, Leslie's building a planter for her front porch. The planter is a trapezoidal prism. At what angle does she need to cut angle A? Okay, so we know this is our trapezoid. We know it's 30 centimeters tall. And we know this little piece is 2.5 centimeters. It wants to know this angle A. And luckily, angle A is part of a right triangle. This is my angle. This is a right triangle because I would draw this so that I know for sure this 30 centimeters is straight up and down. This side is 2.5 centimeters. I can use SOHCAHTOA to find that because I know that I have a right triangle. So my right angle points to my hypotenuse. My angle I'm looking for points to the opposite side, which makes my third one my adjacent. I need a formula that has opposite and adjacent in it. This was all from last chapter, or last section. Opposite and adjacent is the tan formula. So tan of my angle equals the opposite over the adjacent. Fill in what I know. So I don't know my angle, it stays the angle symbol. Opposite is 30 centimeters, adjacent is 2.5. Need to do the inverse tan to get the angle by itself. So my angle, the inverse and the tan cancel. My angle equals tan negative 1 of 30 divided by 2.5, which means my angle equals 85 degrees. That's it. That's all that question wants. We're not going to do part B. Part B is about volume. And volume is not part of your curriculum. It's not something that is meant to be taught in this course, so we can ignore it. Don't do volume. The last one says, Ian is sewing a kite. And he plans to take to the annual Windscape Kite Festival in Swift Current, Saskatchewan. Doesn't really matter. They like to give you context. The context typically has nothing to do with the question. Ignore it. Word problems, cross out anything that's not relevant. All we really care about at this point is that it's a kite, and we've got our dimensions. So it says, what are the measures of angle BCE and angle CBE? What kind of triangle is BEC? So first of all, BCE is that angle right there. CBE is this top piece right here. So there's some things I know about kites. First of all, I know that kites are always at a right angle, which means that triangle from BEC is a little right triangle. This is really helpful to us because we like working with right triangles. We can use our Pythagorean theorem or we can use SOHCAHTOA. I know the height of this triangle because I know that this piece right here is 40, which is the same length as this piece right here. So this is going to be 40 centimeters. I also know the bottom part of my triangle because I know that all the way across is 80 centimeters. And the way a kite is set up, the properties of a kite is that it's exactly divided in half. This midline divides it exactly in half, which means this is 40 centimeters, so half of 80, and this is 40 centimeters, half of the 80. So this bottom piece is also 40 centimeters. What this tells me is that this is a right isosceles triangle. The two side lengths are the same. This actually saves me some work. So triangle BEC is a right isosceles triangle. This saves me having to do sine, cos, and tan because I know from my properties of isosceles triangles that the two angles at the bottom of the two sides that are the same are also equal. So if I go to the bottom of my side, or I guess in this case the top, so all the way down here and all the way down here, those two angles are equal to each other. They're exactly the same size. And my triangle has to add up to 180 degrees. So I know I've got 180 degrees minus the 90 degrees because this is a right triangle and I know the one side is 90, leaves 90 degrees. And because it's an isosceles triangle, each of those angles are exactly the same size, so I divide my 90 by 2. It's going to be 45 degrees. So angle BCE equals 45 degrees. Angle CBE also equals 45 degrees. If you don't like that, if you would rather use your sine, cos, and tan, you absolutely can. If you go back to the triangle and you want to solve for here, across from your right angle points at your hypotenuse, across from your angle points at your opposite, the third one is the adjacent. You can use your tan formula. And if you solve this, tan of 4, or second tan or inverse tan of 40 divided by 40 is going to be 45 degrees. Okay, so it's going to give you the same answer either way. If you prefer the tan formula, use the tan formula. Okay, the last part says, what are the measures of angle EAD and angle ECD? So EAD and ECD, we're now looking at the bottom part of the kite. So I'm just going to redraw what piece we're looking at. So it's across where we've got A, E, C, down to D. Okay, not a great drawing, close enough. Angle EAD, from E to A to D, is this angle up here. Angle ECD is this angle over here. These should also be equal. That's the other property of the kite, is that those outside angles are equal to each other. So I know from my original drawing all the way across is 80, and like I said, that line up and down splits it exactly in half. So this is 40, and this is 40. If I look back at my original drawing, from the bottom to this midline, or where the AEC is 70 centimeters, which means down here, this is also 70 centimeters. I'm looking for this angle. My final property for kites is that kites always meet at 90-degree angles. So I've got right triangles again. I'm going to use either side of my right triangle. I know this is 40, this is 70, this is the angle I'm trying to solve for. So my right angle points at my hypotenuse. My angle I'm trying to solve for points at my opposite, which makes the third side the adjacent. Again, I want opposite and adjacent in my formula, which is tan. Tan of my angle equals opposite over adjacent. So tan of my unknown angle equals the opposite, which is 70, divided by the adjacent, which is 40. I'm going to do the inverse to cancel out my tan, get my angle by itself. So the angle equals the inverse tan of 70 divided by 40. Which means my angle is going to be 60 degrees. And if one side is 60 degrees, the other side is also 60 degrees. They're exactly the same because I could fold them directly in half and they perfectly overlap. The last piece says, what are the measures of BCD and BAD? When I'm looking at BCD, BAD, I'm just going to redraw my kite one last time. I got A, B, C, D. So BCD is this whole angle right here. BAD is this angle right here. And if I fill in everything I know at this point, I know that this is 60. This is 60. I know that from my top piece, each of my angles at the top were 45. So this is 45, this is 45, this is 45, this is 45. That means angle BAD is from here to here, which is 60 plus 45, so 105. And on this side, BCD is also from the top of the 45 to the bottom of the 60. So 60 plus 45, 105 degrees. The last part says how much of each color of material, grain weight, is needed to make the kite in centimeters squared. Centimeters squared is the measure of area. Again, area is not something we have to learn in the curriculum for this course. Don't do question D. We're done. So what I want you guys to do is work on the practice section. So practice your skills, get this done, make sure you ask lots of questions if you have them. We'll do 5.3 next.